Okay, just like a movie, huh? Right at the beginning, the action scenes. So, as Miss Bahlau said, my name is Cody. I'm actually Miss Bahlau's brother. I work on a research vessel run by Columbia University out of New York City. So, we travel all over the world doing different types of scientific studies. So, I know you guys have just talked about the plate tectonics and the rock cycle, right? Yeah?
Did you hear? Yeah.
Yeah. So we'll cover some of that today. We'll look at a little bit of plate tectonics and we'll look at some other stuff, what it's like to live and work on a modern research vessel. So let's look to see where we're at first here to get sort of an idea of what it looks like. So I'm going to share Google Earth. So it's very, very nice for looking at different things on the planet. So I hope everybody recognizes this. This is where you guys are at right now, Grass Lake School. So I have the pin dropped on the outside fountain with the picnic tables in the learning area. So we're going to zoom out. So here we go. So here's the state of Michigan. We see some Great Lakes, Lake Michigan, Lake Huron, Lake Erie. We're going to keep zooming out. And now we see the U.S. And then we're going to come south all the way down here. So this is the country of Mexico. So we're going to come south of Mexico. And this is the area that we're working in right now to collect scientific data. So you see here where it says the Marcus G. Langseth, this is the name of the boat that I'm on right now that we're working. And we'll talk a little bit more about it later, but right now we're acquiring seismic data. So what does acquire mean? That's sort of a big scientific word. Acquire means to gather or to get data related to seismic. So we do two different things on board the boat here. We do geophysical science, which would be like seismic data. It would be gravity, measuring gravity. It would be measuring magnetics. It would be doing sonar studies of the ocean bottom. And we do oceanographic type data, and that's taking water samples. That's looking at the temperature of the ocean, the salinity, how much oxygen, how far down the light goes into the water column, how much turbidity is in the water. So what does turbidity mean? It means if you look at a river and it's crystal clear, there's not much sediment in the river. But if you look at a river and it's very milky, like milk chocolate, then it has a lot of sediment in there, or the turbidity level is quite high because there's a lot of dirt and sediment in the river. So we look at that in the ocean to see what the turbidity level is with the ocean water. So those are sort of the two aspects that we look at on board the boat. So we're going to do a drone flyover first to sort of see where I'm working here. So let's start this. So this is a drone flying in on the boat. We can see the back of the boat right now. And offshore, we have all these different names that we use. So we call this the stern, or the back of the boat. So we're going to come along to the right-hand side, and we call this the starboard side. So here we're coming up now on the right. And in the center of the boat, you're going to see a big gray square. That's called the A-frame. Can everybody see that? Yeah? So that's where we deploy some of the scientific equipment. Deploy means we take it and we put it into the water. Now we're coming up on the front of the boat. This is called the bow. So beneath that big blue line, that's where the captain works up on the bridge with the bridge officers. They're the ones that go up there and drive the boat. So they work up there 24 hours a day. There's always somebody on the bridge. Now we're coming on the left-hand side. That's called the port side. And you see right in the center, there's a big tower. So that's where we have people, biologists. They go up there and work, and they watch out for protected species, whales and dolphins and turtles and different types of seabirds, because we want to make sure that when we're working in a certain area, we're not harming animals while we're collecting data. So that's part of their jobs, is to monitor the wildlife around the area to sort of see, well, for a couple of reasons. They can see the whales and the sharks and how far north they make it or how far south, and they report that information back to the science communities so they understand the migration routes of the different animals. So how big is the boat? Let's take this off. So it's roughly, so a football field is 100 yards long. So this boat I'm on right now is 75 yards long by 20 yards wide. So it's almost the length of a football field, but quite a bit narrower. So how many people are in your class right now? About 20 people? Do you think?
Yeah.
Yeah. So on board right now, there's about 45 people on board. So double your class. So 45 people, all different backgrounds. We have scientists, we have biologists, we have technicians who make sure the computers are running and the internet's working. We have engineers or the mechanics that make sure the engines on the boats work. We have cooks and cleaners. We have maintenance people that work on deck. We have the captain and the people who drive the boat. So all sorts of different types of people that come offshore, and then they work as we collect data. So we spend 30 to 40 days offshore at a time. So we'll go into port, we'll go into dock, we'll get food, we'll get water, we'll get fuel and supplies, and then we leave land and we're at sea for 30 to 40 days at a time. So what do you think if you were going to spend 30 to 40 days on board a boat, what do you think that we would need to have? Any guesses? Water, yeah. So we have water makers on board. So in the engine department, they actually make water through evaporation. So they take salty seawater, they evaporate it, and then we get fresh water from that. So what else do you think we would need?
Food.
Yeah, so food. So as I mentioned earlier, we have these different terms offshore. So at home, you cook in the kitchen. At school, they cook in the kitchen. So we call that the galley here. So here's a picture of the galley. So this is where they make our food. It's actually lunchtime right now for me. So we're on Central Time now. So right now it's 12:20. So they're up there. They have the food out. So it's probably just like at your cafeteria. You get your plate or your tray, and you go through and you pick what you want. So last night for dinner, we had pizza. I don't know what tonight for dinner is, but last night it was pizza and pop. That was quite good. And then where we eat is called the mess room. So you would call it the cafeteria in school. So let's have a look at that. So this is the mess room. So it's obviously quite a bit smaller than what you guys are used to, but this is where we're going to eat. We have ice cream and popsicles in that white fridge in the back. They'll have desserts. We have a salad bar. They usually have a cherry or apple pie or something like that, some type of dessert to go with the meal. So let's see, what else? So we're going to have cabins. So the cabin is where we sleep on board. So this particular cabin has 3 beds for 3 scientists who stay in here. Now remember, we work 24 hours a day. So someone is always sleeping or someone is always working. So sometimes there'll be someone sleeping and then another person has to get up and then go to work. So we have to share the spaces that we're in. So just like in your classroom, you have to be respectful of your other classmates, and you have to make sure you put the markers away or put the paper or put the things back when you're done with them. It's the same off here, or it's the same on board here. When you're in your room, for example, you don't want to step over someone's dirty socks on your way to your bed. So we have to be respectful of the other people that we work with. So what else do you think you'd want to see offshore on a boat? If you had to design a boat, what would you want to have on it?
A playground.
A playground, you said?
A playground? Yeah, lifeboats. That's a good one. Yeah, exactly. So here's a couple. So we do have a gym, not so much a playground, but we have a gym on board. So we have the treadmill, we have weights, we have a rowing machine. What else do we have? Oh, we have a movie room. So here we have a big screen TV. We have guitars. We have Monopoly, board games. We have cards. We have games. We have PlayStation. You guys probably don't like PlayStation, though, do you?
No, they don't play video games.
No, you guys don't like games?
They don't. They don't know.
Yeah,
No, they do.
Oh, okay. Yeah, so we have PlayStation. We have several different games on board. So when people aren't working, they need a space to go and rest and relax and take it easy. We also have a small library on board, so they can read books. They can take it, while they can have a quiet time. This is where the captain works. This is the bridge. So the captain is up here. What's something that so this is where they drive the boat up here. What's something that you think you would see but you don't see it?
A steering wheel.
Yeah, so there's no steering wheel, right? So now what they do is, are you getting some bad feedback?
No.
Okay, sounds okay. Yeah, so the modern boats now, they don't have a big steering wheel. They have a small joystick, and they drive it almost like a PlayStation game. So with the small joystick, they can go forward and backwards, left and right, and they're able to drive the boat like that. So you don't see the steering wheel anymore. It's all done by a joystick. So someone mentioned lifeboats, right? So at the start of school, you guys did drills, right? You did a fire drill, maybe a tornado drill. Did you guys do those?
Yeah.
Yeah. So we do the same thing when we start. So a new expedition, we have new scientists come on board, and we need to make sure that they're trained up and they know what to do in case of emergency, like a tornado or a fire. But we have different drills. So we have a fire drill as well. So when they come on board, we get them all together. That's what called the muster station. And we listen to the captain as they explain different things. So in this picture, you can see the crew has their life jackets on, and they're learning what to do in case of emergency, how to put their life jacket on, how to secure it. There's a whistle, there's a light. So they're learning, how to put their emergency equipment on. Here's another example. So these are called immersion suits. So if we have to get in the water and the water's cold, we want something to keep us warm. So these suits are very thick and they float. So we're able to go in the water with these suits all the way zipped up, and we're able to stay warm in the water. Yeah, exactly right. So what's another thing? If you think that we're gone for 40 days and we're several days away from shore, what's something that you think you'd want on board the boat?
Land.
A bathroom.
Oh, yeah. We have plenty of bathrooms. Another thing would be a hospital. So if someone gets hurt or they don't feel well, you want to be able to take care of them. So the captain is the main medical person on board. So here's a picture of our little hospital. So it has a bed. We have oxygen. We have medicine and pain pills. We have flu medicine. We have some seasickness medicine if someone's not feeling good. And we're able to treat them offshore on board the boat. And if it's serious, we can hook them up to a machine that gives a bunch of data, and we could use a system just like this, or we can call the doctor, and the doctor can have a FaceTime or a Zoom with the patient and try to work through any problems they have. So we have a lot of different ability on board the boat to help somebody if they're not feeling well. So before we continue, does anybody have any questions about the boat or about how we live on board?
What's the name of your boat?
Can you say that one more time?
What's the name of your ship?
Miss Bullock,
What's the name of the boat?
so the boat's name is Marcus G. Langseth. Yep. So it's kind of a long name, but Marcus G. Langseth. It's from Columbia University from New York City.
Rolling. Go ahead and get it rolling.
Do you guys have a laundry room?
Oh, that's a good question. We do have a laundry room. I should have taken a picture of it. Yeah, so just think. So there's 45 people on board. We have 2 washing machines, and we have 2 drying machines for all those people. And we have, just our normal clothes, but we also have our work clothes that get very dirty. So one of the tricks that we do is when we put our laundry in, we set a timer on our phones to make sure that we come up and we can cycle our own clothes through the washer and dryer, because you don't want someone else doing that work for you because people will get upset.
If you're away during a holiday or a birthday, do you do something on the boat?
Wow, what a great question. So we were just on board for Thanksgiving. I came to the boat November 20th. So I was on board for Thanksgiving, and we're going to be on board for Christmas. We're going to get back into port on December 27th. So we try to have fun things on board the boat. Christmas time, they'll have a nice meal. For Thanksgiving, we had turkey, we had cranberry, we had fresh bread, we had dressing or stuffing. So it's quite a nice meal. For birthdays, they usually make a birthday cake for somebody when it's their birthday.
How far from shore will you go?
Yeah. So it depends on what the expedition is. So let's see. So you can see here's the boat right here. So let's measure how far we are. So do it in miles. So right now we are roughly 30 miles from shore, 33 miles. But sometimes we're a lot farther. So in this expedition, we were all the way down here, but we cross the ocean all the time. So for example, we sail back and forth between the United States and Africa to these islands right here. So when we're in the middle of the Atlantic Ocean, we could be 4, 5, 6 days away from being able to get to shore. And the water depth right now, let's see, what's the water depth? So the water depth is 4,500 meters. So 1 meter is roughly 3 feet. So what, that's 15,000 feet water depth? It's pretty deep right here. Yeah.
Thank you.
Is there any women on your ship?
Can you say it one more time, Hazel?
Is there any women on your ship?
Yeah, fantastic question. So we have 45 people, and I would say probably 15 people, 15 women are on board at all different jobs. So we have, a couple different things we do. So we have the biologists on board that look for the whales and dolphins and turtle. We have the scientists on board that do the scientific studies. We have the technicians who make sure the scientific equipment is running. We have the marine crew, that's like the engineers who manage the engines on board. We have the bridge officers who drive the boat. So right now we have, let's see, all of the protected species observers are all women, so they're the biologists. We have several scientists which are women, 5, 6, or something like that, 5, 6, 7. One of the lead scientists is a woman. We have one of the bridge officers who drives the boat. Who else? And we have one of the deck crew who works on the maintenance on board to make sure that, when we want to pick up the anchor, that piece of equipment works. Yeah, good question. Let me see. I think I have a picture. Hold on one second. Oh, yeah. So they're on board right now. So these are some of the science team we have on board. The person on the left side with the glasses, that's the lead scientist. Let's see. Here's another picture. This is, we're deploying the seismic streamer, which we'll talk about in a second. And here's another picture. These two people are on board right now as well. Yeah. Good question. Let's do one more question, and then I'll continue with some more videos.
Okay.
When you come to shore, are you allowed to get off and explore?
Yeah, that's a good question. So it depends sort of what we're doing, and it depends how busy the port calls are. So a port call is when the when the vessel or boat comes from the water and goes to shore and goes to dock. So, and it also depends a little bit on the regulations of the country. So when we're in the U.S., it's very easy to come in and off the boat, no problem. So we come in, for example, to San Diego, California. We're at the dock. We work our 8, 10 hours during the day. And then after that, if you want to go to town to have a nice dinner or to watch a baseball game or go to a museum, you can do that. But in some countries, it's a little bit harder. So we're working in Mexico right now. And I don't know if anybody's traveled internationally, but you have to go through immigration and customs when you come into a country. So it depends on what the rules for that country are, is what the crew can do when they go to shore. So every country is a little bit different, but in general, most of the time you can go to shore. So we were just working in the Galapagos Islands Where's this? So so this is where we're working now, south of Mexico, all the way down here by South America, right on the equator. These are the Galapagos Islands. And when we were here, a lot of the crew were able to go ashore and go snorkeling, see tortoises. So this is one of the videos from our time on shore. So this is some of the crew were snorkeling. You can see a shark come by here. I think that's what is it? Is it a black tip shark? Here's a big sea turtle. So this was me. So I was snorkeling right above the sea turtle. Here's a couple. This is a tortoise. Here's an iguana here. Here's a cut. This is a famous bird on the left-hand side. And here's a couple locals laying on the benches. And what we saw there at the end were lava tubes. So the Galapagos Islands were volcanoes, and some of them are still active, and some of them are dormant. But the lava used to run through these tubes, and some of them are hollow or empty. So they have tours now where you can actually walk through them. Yeah. So let's continue, we'll take some more questions later. Don't worry. So when we're offshore, some of the data that we collect, I mentioned before, is called seismic data. So how this works, it's like a bat. You know how when a bat flies through the air and it makes a sound, and then it listens for the echoes back, and then it can make a picture of the forest, a barn, or a house. So we do the same thing with what we call seismic technology. So we have a cable that we drag behind the boat that has listening devices on it. They're called hydrophones. And then we make a noise. And the noise goes down and reflects off the rocks on the bottom. It comes back up, and we record that noise when it comes back, just like a bat does. And we can make a picture or a map of the rocks below the ocean. So let's look at, let's come back to what we were looking at. So we see here, so you see these three bumps right here. Does everybody see those? Yeah? Yeah, so those are volcanoes. And so right now we're looking at a bird's eye view. So we're looking straight down. So imagine if you had a birthday cake and the cake's on the table. We're looking straight down on it where it says maybe your name and how old you are. But with the seismic data, we can take a cut out of that cake and we can look at it and see the layers of the cake. So we can see the cake, we can see the frosting, maybe some sprinkles, maybe more frosting. And so we can understand how the earth is made. So let's look at an example. So you see here where it shows like the red peaks, the red mountains. Does everybody see that? So those represent those three volcanoes that we saw earlier. But remember, we're looking at the side of the cake so we can see the layers. And the scientists use this to better understand the plate tectonics, to better understand earthquakes, to better understand volcanoes. So if you remember in your lessons about the different plate boundaries, does anybody remember what the plate boundaries are called?
Yeah.
Divergent.
Yep. Lincoln.
Convergent.
Yep. Yeah. Remember the third one. Cause earthquakes. Oh, there's some. Starts with
So
T.
Transform.
Yep. Very good. Transfer.
Yeah, exactly. So that's transfer. Yeah, exactly. So divergent, transform, and convergent. So you see where we're working right now, this blue line. You see this blue line? This represents a convergent fault. So these are two plates. So you have the oceanic plate going underneath the continental, and it's creating a subduction zone or a deep trench right there. And that's what we want to study is that trench, and we want to do seismic over it to understand how those rock layers work together. The sound is still okay? No feedback? Everything's good?
Yeah, we're good.
Okay, perfect. Yeah. So here's a good example of what that looks like. So this is some scientific data from another area, but it's still seismic data, and we can see the layers. Hold on. And we can see the layers in the sediment. Does everybody see that? Where it kind of looks like layers of a cake, the sediment layers in the center. And then on the right-hand side, you're going to see sort of a mountain. Does everybody see that?
Yes.
Yeah. So what you're seeing there is the layers of sediment. That's the oceanic layer. And on the right-hand side, that's the continental. So that's the North American plate, and that's called the Juan de Fuca plate. And the Juan de Fuca plate is coming underneath the North American plate. So we want to study for that. We're looking at potential earthquake zones or volcano zones. So here's some more data that we can look at. So this is called multi-beam data or sonar data. And what we're doing here is we want to make an image of the rocks below the water. So, you look at Google Earth. So let's look at Google Earth. So you look at Google Earth and you say, wait a minute, it looks to me like all this has been mapped. You see all the mountains and ridges. But if we zoom in a little bit farther, do you see how this is real fuzzy compared to this? This is kind of clear. You see a lot more definition. Do you guys see that?
Yes.
So this fuzzy area actually has never been mapped. So they can do a best guess based on satellite data. So they have this very interesting technology where they take a satellite and it reads the height of the ocean, very, very small changes. And through those very small changes of the ocean, they can extrapolate down and they can say, well, I think the bottom here has a canyon, and I think the bottom over here has a mountain because there's very small changes on the height of the sea level. Isn't it amazing? They can do that with a satellite, but it's sort of a best guess because they don't actually have real data that's actually mapped the ocean. So that's one of the things that we're trying to do is we're trying to map the oceans, or the bottoms anyways. So one of the things that we're doing as we work in this area, we have an instrument that's called an EM-122 multi-beam sonar, and we can make high definition maps. And they look sort of like this. So let's have a look at this one. So on the left-hand side, do you see there's like three different colors? Four. Blue, green, yellow, and red. So the bluer colors represent a deeper depth. Now we're looking at this from a bird's eye view straight down. So the blue colors represent a deeper depth, and the yellow and red colors are a shallower depth. So you see in the center where I have that red box, that's sort of like a big valley, like a deeper valley. And then as we come away from that, we're going to see the yellow and red ridges. Does everybody kind of see that in their mind?
Yeah.
Yeah. And if you remember in science class, maybe you've learned about with plate tectonics, maybe you learned about the mid-ocean ridges or the mid-Atlantic ridge. So let's have a look at that. That's where we have a divergent plate boundary. So let's have a look. So this is the middle of the Atlantic Ocean. So there's the United States. This is Africa. So if we zoom in here, so this green boundary represents the divergent boundary. This is where the plates are spreading apart. So we can see right through here, this is a divergent boundary. And if we go back to our map, so I have the same thing on the right-hand side of your screen, where that yellow line goes across that divergent boundary. And we can see where that ridge is and where there's seafloor spreading here at this plate boundary. So that's one of the things that we do as we map sort of the ocean floor. And only 27% of the oceans have actually been mapped. You would think the number is a lot higher, but it's really not. So we know more about the surface of Mars than we actually know about the surface of our own oceans or the bottom of our own oceans.
Hey, Cody.
Yeah.
Is there any rhyme or reason of like where you go next, or like what part of the ocean floor is going to be studied?
Yeah. So when scientists, when they want to study a certain area, they put a proposal together. So they write a paper, and they say, let's say you guys in your class right now, you want to do a scientific study. Let's pick a spot. What do you want to study? You tell me. What sounds like a fun place?
Puerto Rico. Puerto Rico, they said.
Oh, that's a good one. You know why? Because there's a big trench right there. It's one of the deepest spots in the world. Hold on, let's have a look. So here's Puerto Rico right here. So there's a big trench right here. It's one of the deepest spots in the world. Oh, that's a good spot. So let's say we want to do a scientific study over this trench. So what do you guys do? So you as a class, you're going to write a paper, and you're going to have the reasons that you want to study there, what data that you want to obtain. Do you want seismic data? Do you want magnetic data, gravity data? Who's going to be on the cruise? Do you want students to come with you so they can learn more about the future of science? When do you want the cruise to be? Do you want it to 1 week or 2 weeks or 3 weeks? So you write this paper, and then you send this paper to the government so they can review it. Because normally it's the National Science Foundation that funds or that pays for the vessel time for the scientific expedition. So you send in your paper as a class, you send that in to the National Science Foundation, they're going to review it. But they just don't review it themselves. They send it out to other scientists, or in our cases, other classes, for them to review it to see if it sounds okay. You know, is it smart what they want to do? Are there objectives? Do they make sense? Is the time frame, does that make sense with what they want to, with the data they want to acquire? So how many fifth grade classes are in your building? 4 other classes?
4 other, yeah. So 5.
4 other. Yeah. So the National Science Foundation is then going to send your paper out to the other classes. They're going to review it and say, yeah, you know what? This sounds pretty good, and it's going to give value to the scientific community if we find out these questions that your class wants to know. So the National Science Foundation comes back and they say, okay, we're gonna pay for your project, and then you're gonna contact us to get time on board the boat to come do your work.
Cool. Okay, thanks.
Any more questions? Right, let's do a couple questions.
Okay. There you go, Lincoln.
Do you get paid for being out at sea?
What's that?
Do you get paid for being out at sea?
Yeah. So the people who work on board, this is our job. I'm on board the boat 180 to 200 days a year. So almost 6 months a year I'm here, but not all in one go. So I come on board for 4 or 5 weeks, and then I go home for 4 or 5 weeks, and then I come back. So this is my job. I've been doing it for quite some time now. So I started in 2001, and for everybody else who works on board, it's also their job as well. Yeah.
What's your job?
So my job, yep. So my title is Chief Science Officer. So my main job is I'm the lead technician on board the boat. I make sure that when the scientists come, all the laboratories are ready for them to acquire data. All the scientific equipment that we have on board is in calibration and it's ready to work. So we have all the seismic equipment, we have the gravity equipment, the magnetic stuff. We have winches and different things that we use to be able to collect data. So I make sure that's all working. And I also, when the scientists come on board, I work with the scientists to make sure that they can achieve the goals that they want to achieve.
Have you ever saw any whales before?
Yeah, so we see whales quite a bit. So now this time when I'm on board, we haven't seen any whales, but normally we always see whales and turtles, dolphins we see all the time. We see humpback whales quite a bit. Yeah, all sorts of different types of whales. So sometimes the seas are real calm, like in the picture behind me here. Sometimes the seas are real flat, but sometimes the seas are real rough as well. Here's a good picture, a little video of the days when the seas aren't too calm.
All hands, hoist the colors high. Heave ho, thieves and beggars, never shall we die.
So who wants to work in seas like that? Anybody? Yeah, a couple. Yeah, yeah. It gets pretty rough sometimes. Who's sitting there at the front table? Are there some water bottles on the table? I see a clear one with a red cap. Yeah. So when the seas are rough like that, you see your water bottles. They wouldn't be on the table very long. They would fall and roll off, and they'd be rolling on the floor. When we're offshore on board the boat, everything has to be secured and tied down with Velcro or bungee straps or anti-slip pads. That way, everything stays place. You imagine if you're at the cafeteria and you're eating your food and the boat rolls, your piece of apple pie is going to slide down to the next person.
Will you pass that to Brinley, please? Give it a second. All right.
How how long does it take to get from sea to shore?
Yeah, that's a good question. So how long does it take? So let's have a look. So how fast, well, before we do that, how fast do you think the boat goes? Can we guess?
Go ahead, you say it.
20 miles an hour. 30 miles an hour. 30 miles an hour.
Yeah, so I think I heard 8, 20, and 30. So our max speed is 10 knots. So it's basically 10 miles an hour is our max speed. So it's pretty slow compared to a car, but you remember that we go 24 hours a day. So every day, if we travel at full speed, we can go 240 miles. So let's do a little exercise. This is what I was doing today, actually, when I was planning for the end of this expedition. So let's have a look. So I want to know how long it's going to take us to get from our current working area back to port. And we're going to go to port is in Manzanillo, Mexico. So I just did this a little bit ago. So let's have a look. So this is where we're working at now. And we want to go up to this port, which is called Manzanillo. Let's zoom in. Yep, Manzanillo. So how do you think I do it? So using Google Earth is quite a good tool. So we're going to bring out our measuring distance again. And we're going to switch to nautical miles. So there's a difference between miles and nautical miles, which I'll explain in a second. So let's click, we want path. So let's click here. So let's, right where we're at right now. So we're going to make a path. Let's see about there. And there, and there. So we have 261 nautical miles. So how many hours do you think that's going to be?
think about how fast it.
So it's 261 nautical miles, and we go 10 knots an hour.
How many hours? That's 20 miles. That's 20 miles. 260 miles divided by 10 miles per hour. Or not. About 26? About 26?
Yeah, exactly. So it's 26 hours. So you see, when your teachers say that you'll use math someday, I use math all the time. Yeah. So it's 26 hours. So what we do is we know that we want to be in port on the morning of the morning of the 26th. So then we have to go backwards to find out when we have to leave our current work area. So it'll be sometime on Christmas Day morning is when we have to leave to be back in port. Yeah. Did that answer your question?
She said yes.
Good.
Any other questions? Or you want to get across the brook? Great. Maybe toss it to Tyler, and then Tyler will toss it to Brooke. Ooh. You got that? Toss it to Brooke, Brecken. There you go. Good job.
Has anyone ever fallen off the ship?
No, nobody's fallen overboard. So we have different things that we wear when we work to make sure that that we work safely. So we saw the picture of the life jacket. When we're working on deck, we wear coveralls like this with high visibility. We wear a life jacket. We wear a harness. Let's watch a video. We could see some guys deploying some stuff into the water. And if you look closely, you can see the harnesses on their back. So I don't know if you could see them. It was probably small in the video, but they're wearing a harness and they're strapped to the boat. That way, if they slip, they're going to stay on board the boat and not fall in.
Anything else?
What's our time look like, Ms. Bullock?
We have 5 minutes.
Okay, let's keep going on questions. Well, there's been some good ones today.
You remember it, Ro?
No.
You forgot? All right, and it's okay. We'll keep down.
Have you ever had like a dog on ship?
No, so in the past, a long time ago, they used to bring cats and dogs on board. Nowadays, we don't really do that anymore. It comes kind of down to hygiene and also the quality of life for the dog or cat.
Who is it, Lane? Who is Lane?
How much do you get paid for being on the ship?
Well, that's a good question. But let's say it's enough to come out and have fun. Here's another video. So this is what we're doing right now. So after we get done gathering seismic data, the scientists on board, they look at it and they want to look for soft areas so we can drop a big heat probe down into the sediment. So do I have a picture? So the heat probe takes the temperature of the ground below the ocean, and it goes in about 6 to 7 feet. It goes in. So here's a high-speed video of us recovering that heat probe. So remember that A-frame I talked about? So the heat probe, that's the top of the heat probe, that orange weight, and that gray stinger or probe is what actually goes down into the sediments. Here's another little high-speed video. This was us deploying it. Can you guys see? Is it coming across okay, or is it coming choppy?
Nope, it's good.
So there's a lot of people working on deck when we have to work with stuff like that.
Any other questions? Oh, Brindley. We tossed to Brindley.
Have you ever gotten sick on the ship?
So some people, when they come on board for the first time, they get seasickness, and it really comes down to just luck. Some people get seasick, and some people don't. There's nothing really you can do about it. You can try to mitigate it or help it, but at the end of the day, it's lucky. So I never have, but most likely I just haven't seen seas bad enough to get sick. So what we suggest when people come on board, there's different medicine that you can take. You can drink plenty of water, eat crackers. You can go lay down. Usually it lasts for 1 to 2 days, and then you start to feel better, and then after that, you're much better.
Anything else, bro?
How long have you been on the ship since you went to shore?
The vessel here normally stays out for 40 to 45 days at a time. So we'll leave shore, we'll go out and work 40, 45 days, and then we'll come back. That's the longest we can stay out for fresh food, vegetables, lettuce, and things like that. I've stayed on board the boat for 105 days, but that was going offshore, coming to port, going offshore, coming to port, before I finally went home.
Anything else? Brecken.
What's one of the most important parts of like learning more about under the water?
So there's quite a bit to. What's one of the important parts about learning what's under the water? Is that was the question?
Yes.
Yeah. So that's interesting. Every objective we do is a little bit different, and it depends what the scientists on board what their goal is. So some of them they want to look at the temperature and salinity to better understand the ocean currents, to better understand the food chain for how much plankton is in the water, how many fish live in the ecosystem. Or some scientists want to study geophysics and earthquakes and volcanoes. So I don't think there's really one objective that's better. It just depends on the point of view of the scientists who come on board. I would say one of the best things that I do on board the boat is students who come on board a little bit older than you. They're in university, but they're still students. They come on board and they want to learn and they want to understand how data is acquired and how science works in the field. And part of my job is I help them learn and help them grow as students and become professionals.
Good. That was our bell. So we are done. What
Okay.
do you guys think?
Okay, thank you. I appreciate it. You guys have a good day. Bye-bye.